Running after you've already built it in production environments. I'm Sean Chittenden. I'm working engineering at HashiCorp. I've been in production operations for getting close to 20 years in many different capacities. I have an affinity for databases and performance problems. But today we're going to talk about this life cycle here, where you push something, and this is using the HashiCorp development suite, where you do development, vagrant, and eventually you push whatever it is that your innovation idea into production. And what does it mean to be production ready? So, background on production ready is background on coffee. Background is complexity management is the name of the game. So we're going to start off with a really simple service, an echo service. All this echo service is going to do is it's going to print out echo. So in this case, all of the examples that I'm going to give here are all written in Go. But what this particular service does when you go in and run it is it spits out exactly what you've got. It's a nice and simple thing. It literally does nothing other than print out a response over HTTP. So what are the components in this particular service? It's just a little HTTP echo server. So what do we have that's involved here? Well, we have the actual echo service itself down at the bottom. We have a load balancer, and that's it, right? It turns out that there's a little bit more to it than just those couple things, because when you actually kind of get into it, you actually have the hardware and the operating system on the backside there that's running the application itself. Okay, fine. So then we've got a bunch of other things that we need to start monitoring on the actual OS and the hardware there. We need to deal with the logs, and we need to get some kind of reproducible build, because at the end of the day, we need to get that exact same HTTP server back onto that same box so that if we have to recover, we can. So reproducible build, we actually now have to manage this extra chunk of metadata. So it's a real simple little thing, but now we're up to close to 10 different kind of concerns that we have to pay attention to get something into production. So, not big by any stretch of the imagination, but it starts to add up. So then we have to monitor the individual dimensions of the service itself, and those are pretty standard, but again, it's additional little bits of complexity. And eventually it starts to add up. And that little logging server, turns out that not only is it also returning a response, it's logging to disk, which means that you have a liability, because logs will eventually consume everything, or all the space, if you leave it unchecked. So complexity factor, roughly 10, not high. So as operations go, we are concerned with uptime and loss aversion. So one of the primary things that we have largely been trained to care about is uptime. Okay, fine. But there's other forms of loss aversion that we need to pay attention to. So secrets, we want to make sure that passwords don't ever leave the environment. We want to make sure that from a loss aversion and planning perspective, that we've taken into consideration all of the planned failure modes, where things that we expect to fail will fail. Dying servers is a good example. We also need to go and take into account unplanned failures, the loss of a data center in the event of an earthquake. These are things that we don't generally plan for, but we do need to plan for, right? Especially as our business starts to grow. We also need to pay attention to success failure modes. This is an interesting one, because in microservices kind of world, if you have and launch one single service in your infrastructure, and it becomes popular, or it becomes adopted, or a key part of the entire organization, all of a sudden you may find out that your failure mode is actually success. Your API endpoint is being called tens of thousands or hundreds of thousands of times a second, and you didn't exactly expect that to begin with. So that's a different kind of failure mode that is a good failure mode by all accounts, but it's still a new failure mode that you have to deal with. Then when you have this thing here, you have these architectural limits. In the case of the echo server, we know that it's only going to respond at, let's say, 65,000 context switches a second, which gives us about 100,000 requests a second if you've got good pipelining. So there's a limit there. We need to be aware of it. We expect it to fail at this particular threshold. Okay? And then we have the unknown architectural limits, things that we don't expect to fail that may actually fail. And this is where things start to get a little ugly, because if you run into unknown architectural failure modes, you're going to have to go splunking into the operating system or pulling out some interesting tools in order to go figure out what exactly is going on and where this limit is. And this is just for, again, the simple stateless service, the echo server. So when you go and look at something like a stateful service, like a database, the complexity gets, is multiplied even further. So in the case of Postgres, we have, a connection pooler. Okay, that's a separate box. We have to handle some form of point-in-time recovery. So we have wall files being streamed off someplace. We deal with that with one of a handful of different types of processes there. We deal with log files. We need to go and figure out what the slow queries are. Fine. We have to go and put some kind of a metrics agent on there because it's a database. There's a lot more moving parts, typically disk. You have to figure out how you're going to handle failover between leaders and followers. You don't want to have to, have this happen, the failover happen at human timescale. You want it to happen at machine timescale. Therefore, you have to introduce yet another service to go and handle your failover. Failover for databases includes not only the failover of the A record or the IP address, you're failing over state, and state is a single point of failure. I'll come back to that in a bit. And you have to figure out how you're going to handle your schema versioning too. Going back to the metrics, there's a ton of metrics that you need to pay attention to in the for databases that you really didn't have to pay attention to for the echo server. In the case of the database, you've got a bunch of metrics inside of the database that you care about. You have lock contention because you're pulling from many, many different types of resources. And databases have this neat property that they are a point of serialization, which means that they are inherently contentious. So complexity factor, database, 30-ish plus, times the number of tables and the amount of data that's there. It ends up being a pretty large animal on the network. Real quick tangent though, don't confuse complexity of databases with it not providing value. Databases provide an amazing service on the network, and they unfairly get picked on. Myself, I like to pick on them. So managing complexity, you've got these two simple services, just a simple database and all of its constellation of processes. You have an echo service there, and it's relatively small set of failure modes. So how do you systematically address these kind of necessary and inherent complexity? So you have different types of strategy. You can hope that you're going to do something or that the system's going to work as expected. You can hire somebody skilled to go and deal with this and hope that they can just kind of divine the correct outcome and you'll end up in a happy place. That doesn't typically work out very well. You can take what hired skilled labor had done in the past, iterate on it, and refine these bespoke processes that were one-off. And you can copy and paste things from Stack Overflow, because that always works well. And you can embrace the Google search and continually look up and follow your way through to success. You can fall into the arms of consultants, and you could build checklists. And this is what we're actually going to fall back on here, because checklists work out well as a strategy for dealing with complexity. And some of these checklists we can actually build into automation. So, because as complexity grows, we need to fall back on automation and systems, but there's a mismatch between what we need as a business for maintenance versus what the systems actually do at runtime. So checklists kind of come in two basic forms. They come in the read-do type checklist, where you read a step and you do a thing, or you have the type of checklist where you do something and then you fall back on the checklist to confirm that you did the thing that you expected. The do-confirm checklists are there to help catch muscle memory fatigue, or things that you shouldn't forget but you sometimes do. So what we're going to do here is we're going to step through building a modern operations checklist. So checklists are not terribly popular in the technical world, but they're very, very common. Who uses them? Astronauts, surgeons, pilots, inspectors, military, and not us. We generally don't. There's a mismatch between technology and the use of checklists. You can get into the semantics of audits and checklists, and we're going to kind of split that hair here a little. But we generally don't use checklists. So there are good checklists, and there's a couple of attributes to good checklists. Notably, they have clear purpose. They're brief in size. They focus on what's necessary and essential. By this, I mean a checklist does not replace instruction. It does not replace teaching. It does not mean, just because you have access to a checklist does not mean that you can go ahead and do the procedure if you are untrained or unskilled. But they enumerate what must be done. You can't forget steps that are on the checklist. That's the whole point of them. Reduces cognitive load as a result. So, and while we're going through making decisions, checklists do not replace your judgment. This is a really important point as well. Because they are itemized out, it enforces discipline. You make sure that you have 100% compliance with whatever it is that you ship and push out the door. And because checklists are typically designed as group communication mechanisms, they foster good communication between multiple people. So, as an example, just because you have access to a checklist, this is the surgical safety checklist. This does not mean that you can go and operate on somebody, but it does mean that if you employ a checklist like this, you will actually see, in the case of the surgeons, the number of percentage complications associated with surgery went down universally wherever a checklist like this was deployed by 35%. You have highly skilled people that were making errors, simple errors, because of just oversight and fatigue, and checklists resolve that. So we're going to go back and we're going to build this checklist/audit. So in a production-ready system here, there's two kind of concerns that we actually need to address. It's not just the Echo server and the database, it's the Echo server and the database plus the organizational concerns. People need to be involved. So in order to build a organization or a culture that will be able to maintain a system going into the future, you need to have a couple of things in place, prerequisites. So one of the important organizational things that you must establish inside of an organization that's going to be maintaining something for multiple years, because at the end of the day, we're going to write something, we're going to put it in production, and we're probably going to move on to something else. So the organization that takes on the responsibility of maintaining something throughout the long life cycle, the duration of the service's lifetime, you need to have some basic standards. And one of those standards is a definition of jargon. You can't have multiple people running around inside of an organization using different sets of terminology. Communication will break down, and as a result, you will end up in a worse situation. So you also need to figure out, along with your standardized jargon of Sev 1, Sev 2, you need to figure out a naming convention. This is really important in order to refer to things in correct order. This allows for precise communication. So in this case, I'm going to pick on console as a way of enforcing the unique namespace. In this case, this is an ACL snippet that you would use, and you would drop this into a console config. And this one would allow for reading of the app1 namespace. Just because you define a policy, let's say app1 as the namespace prefix or dbn, whatever, doesn't mean that it's enforced. Sometimes you need a control that will enforce this uniqueness. Similar, if you need to allow something to write to a part of the namespace, you can authorize that. Having some kind of a basic control like this that is in the infrastructure that you're using to deploy to production is really important. So inside of a namespace, you need to be able to refer to specific things. Making this common language standardized is really important, especially as teams grow and you get past 20 people working on different projects. So once you have something in production and you have an outage, you need to figure out how and what you're going to do in the event of an outage. And that needs to be standardized across services. And all participants in prod ops need to agree on what those rules are. And that means you need to figure out how you're going to identify a problem, how you're going to respond to the outage, who's going to handle the recovery, right? That's setting up and identifying an incident commander. You need to figure out what you're going to do after the outage in order to put in place the appropriate steps for prevention. And then once you have prepared or prevented future outage, you also need to prepare for additional workload. So, great. This sounds nice and all. You also need to put together the documentation. So centralized documentation is really important element of this, because when you have, let's say, 100 different microservices running around, you can't go digging through everybody's GitHub repos potentially in order to go find the little nugget of information that you need in order to restore service. So then you need to also establish a culture of systems thinking. And this is an important and interesting element here, because systems thinking is changing the way that we as people think, and we're all very talented, specialized people, but we actually need to pivot and think in terms of a, not as individuals, highly skilled individuals, but we need to think in terms of, hold on half a second here. I lost something on my notes. Oh, that's irritating. Okay. Sorry. Systems thinking. It's about thinking. Systems thinking is the process of creating collective understanding and collective intelligence, as opposed to relying on individuals that are highly skilled. That shift in thinking is difficult because we like to think that we're good and therefore we can jump into things. But really, it's a collective understanding of what's necessary in the system. So prerequisites for systems thinking here is, identifying and outlining that a system is made up of its composed parts. Systems are encapsulated, and one of the most interesting and difficult problems to deal with is systems can overlap. And if you have systems that have overlapping concerns, that's where you typically run into nuance and complexity, that where you have tribal knowledge and understanding. And it's one of the sticky areas of systems in general. Anyway, end-to-end ownership means that if you have a person who puts something into production, that they're going to own that thing for the rest of its life cycle until they transition that ownership to somebody else. And as a company, you need to, or an organization, you need to instill that policy so that it's not, I developed it, I pushed it into production, and I kicked it off, and it's somebody else's problem. You own that for the life of that service in production. And this one's an interesting one. Decoupling service names from team names. This is an organizational trait that I've seen repeatedly, where teams, a collection of people will come in and they will put something into production, and they will put the thing that they created into production, and they will name it after themselves. Don't do that. That's an anti-pattern. What you want is you want to have like the team be able to come together, create something, put it into production, and then disband, or put it into production, and then take the thing that they put into production and create a V2, V3 version of it and cannibalize it, not in place in the same name, but move to the new service name. And that's typically hard to do when you rely on the same sets of service names. Anyway, so why do we care about any of this, right? This is all just kind of bureaucratic weight. It's because we're not going to be the ones working on our code for forever. At some point, we're going to put it into production, we're going to move on to the next project, or maybe we're going to leave the company, and the company's going to be stuck with whatever it is that we produced. In the case of payments processors, right? You don't want to be in a situation where, like, a team of people come together, and this is a real life anecdote, built the payments processing system for a company, and then all simultaneously leave the company at the same day. Right? A year later, poof, they just disappear. you need to be able to have that kind of business continuity from a production perspective. So what we are looking at is, what do you have to do in order to build the right culture and the right set of systems so that you can ask the right questions of people putting things into production in order to facilitate maintenance of these systems at month 6, month 12, 2 years, whatever. So we're going to go into the actual checklist for a service, and this is, we're going to bounce through a bunch of points here. This is intended to be an actual like living artifact that people can borrow from. So it's a little wordy, a little long. I'm not going to touch on every bullet point. But when you submit a service to go into production, you need to put together a basic overview. What does this service do? How does it relate to the rest of the business? Right? That includes a short description of why it's important. Doesn't need to be long. Somebody's going to have to read this in the middle of the night. You want to figure out who's current owners of this so that you can go and bug them if you need to. You need to figure out if the service is stateful or stateless. It's real simple, yes or no. But this changes the operational characteristics. Stateful services, you obviously can't just kill. Stateless services, you can. Stateless services are really easy to auto-scale. Stateful services are not. Is there any caching? If there's caching, that's normally a good thing from a performance perspective, but it's another really important moving part because potentially you have stale data running around in your system and you need to know whether or not you have to go and chase potentially stale data. And if you are not using Go, you need to figure out what your dependency management strategy looks like. If you're using C or C++, this is typically a pain in the But if you're using Go, it's really self-evident. The reason that this is important is because of security concerns. Enter OpenSSL vulnerability of the week. Technical note here. One of the things that's interesting if you're using some kind of a job scheduler, in this case, this is the fragment of a Nomad job scheduler here. One of the things that you can do is instead of like commenting this up and putting in notes inside of the job file itself, you can actually use the metadata field here in order to encode some of this information so that you can go back and programmatically refer to this stuff. And you can extract this as the source of truth. So in this case, the job file here includes a list or a pointer to the owners, a pointer to the docs, and some kind of a systems URL. And this is just by convention. But as a result, you can write something that will programmatically go back and enforce consistency. And that's a really important element because at some point as you grow, you can't rely on people to enforce process. At some point, you're going to have to rely on technology to do so as well. A question from the audience here, which is, if one person owns a service, how do I handle handover? And what kind of risk management do you apply? Or do you just rely on good documentation left behind? That's a really good point. I'm going to come back to that in just a minute here when we get to training. So, yeah, so this is a systems there. Let's see. So yeah, you can go back and you can write something that will actually pull and extract that job metadata information out of the, in this case, the Nomad service, and then you can begin to write automated tooling around this convention that you've established. And these fields this is free-form set of fields inside of the meta. That's all key value. So you can go back and you can put in additional slugs or additional keys in there that are relevant to your business. Not everything that's described here is going to be relevant to your organization because from a risk management perspective, you get to decide what's important to you and what's not. So going back to this checklist here, you need to establish a set of high-level consumers. The API is going to be consumed by who inside of the organization. Maybe it's internet facing. Maybe the marketing team is going to have access to being able to dial up, dial down experiments, and you're going to do some A/B testing. They're going to push an experiment to go and figure out if service A or service version 19 works better than service version 20, and they're going to leave that experiment on and cause problems. Maybe customer service is going to have access to this. When you have a service that's running inside of your organization, maybe the fact that you have the service is confidential in and of itself. You need to denote that somehow. And it's really useful to be able to have the actual authoritative information with regards to what you can talk about publicly also reside inside of the repository itself. So, okay, fine. Now you've got this, you've gone through the kind of like the summary boilerplate type information. Now you need to, you're concerned about the incident response and the release process, because maybe there's some kind of a P0 Sev1 type bug, and somebody who's on call needs to cut that release and get it out the door. So you have to establish this process. So what's that on-call process look like? Who's the fallback strategy? If you've got a small team with like 2 or 3 people that wrote the service, and life happens and those 3 people are unavailable, then you need to be able to figure out what that escalation is. You can't not have somebody pick up the page when something breaks. You have to have some response. So what's that fallback strategy look like? You don't want to put everybody on a 24/7 pager duty cycle, but at some point you're going to have to figure out what it is that your business is going to do. And those people that are on call are going to have to be able to manage the release of getting some kind of a bug fix out potentially. So once you're dealing with an incident, how do you deal with installing the service? How did you configure the service? And these are 2 separate things, right? One of them may be like, how did I install Apache, whatever. And how do I configure it? Is there configuration management concerns that I have to deal with? Especially if they're not standardized across different teams. If teams use different tools, different operating systems, then this standardized configuration management process becomes a larger headache. Not everybody uses Puppet. Some people will use Chef. Other people will use Ansible. Some people will cook the config files into the image themselves. So when you have this process, how did it start? How can I stop it? Did I kill it? Can I kill 9 something? That'd be great if I can. But in the case of Postgres, if you do that, we're likely going to have a corrupt database. And that's going to be its own problem. So you can't take for granted that you're going to be able to sig kill or kill 9 a process. That needs to be all documented up front. The process management that's in use, is it platform specific? Solaris or Illumos uses SMF for its process manager. Ubuntu 16 has systemd. Ubuntu 14 is using Upstart. You need to understand some of this stuff up front and ideally abstract away from that. This is something that's actually a pet peeve of mine, is the fact that process management is very, very, very platform specific. There's no common process manager that typically runs across platforms. So you have to retrain bespoke process management for every single OS and sometimes OS version or distribution version. So is there a way of mapping the tables or mapping signals to the consequence, cause and effect? In your process management, is it hooked up into any kind of alarm or monitoring? If you have a process that's flapping once a week, maybe that's just a warning. But if it flaps 10 times, that's probably worth alarming on. And so you have to have that kind of long-running understanding that there's some event that's happening with a process if it's under process management. You can't just assume that because it's network available that everything is okay. A process may restart very quickly and be available, but it's still crashed for whatever reason, and there's an ongoing issue. And if you don't have your process management hooked up into monitoring, then you're apt to not detect a potentially serious bug. How do you figure out what the definition of health is for a service, right? Is it just up, down, very Boolean? When a process is up, and is it doing no work? Does that mean it's healthy? At some point, you're going to have to establish some kind of a KPI, a key performance indicator, that's going to establish the definition of health for a given service. Not all services will share the same definition of health. And one of the interesting problems with any kind of a definition of health is typically seasonality. The worst thing you can do is get paged on, let's say, Christmas morning because something went to 0 for an extended period of time and it was completely benign. But your definition of unhealthy was no database transactions within 1 hour. Okay, fine, but I wasn't expecting any, for instance, on Christmas Day, right? And as a result, you're going to get paged. And yeah. Been there, done that. If you do need to go and figure out how to do simple break-fix type health checks, one of the nice things that you can potentially do is ship that with the application itself by including this particular, or like including a configuration slug like snippet like this with the actual application itself. In this case, this is a health check that Consul would run. That health check happens at the edge itself, so you don't have to worry about centralized monitoring if you have Consul deployed in your infrastructure. Yeah, seasonality. So how do you observe the service? So let's say it's up and running. Use UTC for everything. Yeah, couldn't tell you. I'm not aware of anything there. Yeah, I would say standardize on UTC, and then I know that's not the answer you were looking for. Yeah. How do you observe the process? How do you figure out like what it's doing? At some point, you need to be able to reach in and poke it, because if you're not the person that wrote this service, you need to have some way of being able to figure out, up, down, or just kind of get an assessment of health. How is this thing that's in production doing? And is there any way of doing capacity planning? Because you kicked off a service, you put it into production, time runs forward 36 months, and whatever box or set of resources that were on that that service was relying on is potentially hitting capacity. Had this happen with caching services, where they will run forward, and eventually they don't run out of memory, they start evicting at a very, very high rate. And as a result, you have the box is at a capacity because it needs more memory than it's got, but it doesn't actually present as a symptom that it's out of memory. Instead, what it presents as is the eviction count goes up, and the symptom that you actually see is that over here your database is actually starting to see an increase in load because your caching over here is starting to run out of memory. At some point, you need to figure out what those necessary resources are, and you need to put that are important to the service, and you need to put some kind of capacity planning around that. Customer service, at some point, customer service is going to get involved because you're going to have a user issue. Not all software is bug-free. And customer service is going to need to figure out and how to poke at this without you being around if you're the one who wrote it. Do they have, when you give customer service access to this, do they have access to customer information, like raw customer PII type data, personally identifiable information? Yes or no? And if they do, then you need to begin thinking about auditing and the appropriate controls there, because if you have a bad actor in your customer service, they can walk off with real legitimate customer data. Quality metrics. When you put something into production, you need to figure out the health of this particular service. How do you measure the intrinsic steps involved in an organization supporting something that's in production in order to figure out if the thing that's in production is actually healthy to everyone's satisfaction? Getting accurate information from customers is an interesting one. Depending on what your business is or how you get that, there's a lot of different strategies that you can employ. Don't rely necessarily on web forms, but this one in particular has resulted in many rabbit holes where you start chasing the wrong problem because you have bogus information coming back from a customer. Figure out how to get accurate information from a customer in an automated way so that you don't have to go back and forth 1,000 times. And sometimes that customer may be an internal customer, not an external customer. So you can't assume that even your internal customers are going to give you the right data. And then going back to that comment earlier about PII, measure the rate of access. This is really an important one if you do have to deal with PII information, like if you're dealing with banks and other secure or other organizations that handle potentially secure information. So that's nice and all. Those are really hard metrics to potentially go and figure out how to pull, unless you decide as an organization you're going to use some kind of a centralized issue tracking system where you can begin to kind of piece together or kit together the appropriate metrics in order to provide you, the business owner, with some kind of understanding and insight as to what's going on. So an outage is not necessarily, not all outages were created equal. Some outages are worse than others. And so you have to define what an outage actually means. So as a business, one of those prerequisites when we were talking about standardized jargon is how do you define what the difference is between a SEV1 and a SEV5? And I would put to you that SEV4 and SEV5 is pretty useless. But as an organization, you need to decide what is important to you and what's not. Do you use severities like this in order to prioritize work? Who knows? But you're going to have some kind of an outage at some point in time, and you need to figure out what the impact to your business is going to be based off of these severities. So at the time that you submit something to production, you should have an understanding of what the consequences of different types of outage are going to be to your business. Some types of outage are going to be inconsequential. Some types of outage are going to be catastrophic. And having an understanding of that up front is really important in order to figure out how you address the situation. One of the important bits there in this sample table is the escalation. At what point do you escalate, and what does it mean to escalate? How do you escalate from a SEV1? You go to a SEV0 where it's all hands on deck? Who knows? But you need to ask those questions before, because you go into production, because at month 18 when something goes sideways, that's when this pre-planning goes into effect. The indirect and direct consequences of an outage at each one of those severity levels is not necessarily the most pleasant thing to have to go and figure out or begin to suss out, but that dramatically changes and enables the organization's response. So tracing is a really kind of vogue thing these days. How do you set up tracing? So tracing is if you have an entry point into your system, it injects a random token, and that token follows the request through all of its different microservices, that you can go back and figure out where time was spent on the network or in process to go to. Yes. So you want to standardize on tracing, though. Whatever tracing you decide you want to use, or if you can use tracing, you need that to be standardized. You don't want to be in a situation where you have two separate types of tracing that are standards that are in use. When you have a tracing library that you have selected, however, you need to make sure that that tracing token gets included in all requests. And this is an interesting convention/technical problem. You have an organization that's standardized on tracing technology A, and you have client libraries that are just going to make HTTP requests and not pass this along. Now that you've made this kind of cultural decision to go and use tracing, you have to go and flush that through to completion, which means that you have to wrap all of your API requests to pass on the token that it received as a server, or as a service, and you relay that token to all of its downstream customers. Getting complete coverage takes a lot of discipline and work. When you put something into production, this is a good time and opportunity to go catch some of that. Unplanned failures, geographic redundancy. Right? When your data center melts, what can you do about it? Right? If you can be geographically redundant, can you do it automatically? Right? If you're not doing it automatically, you're going to have a bad time because you're never going to exercise this. So how can you put something in place to handle the geographic redundancy? Going back to console, one of the things that's really neat here is you have the ability to have this happen at machine time, where console will return back a DNS response to the next nearest data center and do so automatically based off of the current network health. I've given other talks about how to do this with Postgres across multiple data centers. This is a really, really interesting technology and technique because this all happens at machine time now. Normally, doing data center failover, you have to pull the big giant red lever, and it's a manual process. Where possible, use automated systems like this. So does it happen automatically? Are there regulatory concerns? If you're failing over between different data centers, do the data centers span different countries? If they do span different countries, are different regulatory concerns coming into play, like safe harbor, right? I know that I can't fail over from an EU data center into the United States without having to deal with PII type concerns because of privacy legislation. It's just different between the two continents. If it's manual, or if it's not manual, then how do you what's the time scale there, right? Is it machine time or is it human time? That's the most important question that you kind of have to keep coming back to with any kind of a failover. And in the case of geo failover, how are you testing that failover path? Are you taking some percentage of your traffic and sending it to the other data center? If you can, send 1% or 0.5% of traffic to the other data center in order to test your failover so that you're continually testing things. Can you make your service active-active? You really want to be in an active-active world, but you can't necessarily do that with all services. Database services you can't do that with terribly because you have a single point of something, which is the state. You have a leader, you have followers, but there's only one leader typically, especially in relational databases. So you can't run those active-active. Stateless services, no problem, right? Not necessarily though, right? You may have locking and sharding concerns. There may be other downstream services that prevent it from being very simple. Just spin up 3 copies in each location. Data classification. Is this PII, personally identifiable? What regulatory domain? Lots of different kind of concerns that you need to potentially unpack if you're touching data. Is any of this PII type data going out into a log provider or into a logs? Is that log data or that PII information potentially leaving to some other third-party processor? Lots to unpack there. Making sure that some of this stuff never touches disk is particularly difficult at times. Single point of failures, how do you manage those out of your organization? You can up to a point. I just said you can't get rid of them with relational databases right now. So what do you do to minimize them? Identify them, figure them out, and minimize the scope, and provide automation in order to deal with the failover so that it happens at machine time and without human intervention. And if you go down that route, how do you prevent split brain? One of the worst problems to have to go and untangle is taking a database that has failed over and continue to accept writes. And in that case, you've got a divergent copy of the world that you've been making making writes to and mutating. And then you're going to have to reconcile this because both databases have different copies of the data at this point in time, and you're going to have to reconcile that. So you very much want to figure out how to prevent split brain. Escalation. So you've got some kind of a problem, and you don't necessarily understand what it is that you need to do to fix it. Okay, fine. You need to escalate. Who do you escalate to? Sometimes you can escalate to an internal resource, but it's also really good to know who you can escalate to after the fact. Not after the fact. It's who you can escalate to out of the organization potentially. Figuring out escalation from on-call stuff may mean that you have to wire up some form of automation where you have automated escalation inside of the company using PagerDuty OpsGenie, but you also may need to figure out who your escalation path is to external providers. What you really want to be in a position, though, is that as you fail or build out your organization, you can fail over to other groups and other teams, other people, because you have fungible skills, which means that you've started to standardize on processes inside of the company. Health isn't necessarily a binary thing, as I mentioned earlier. You want to be in a position where you can actually set up some kind of a probability curve and say, if latency for the TP99 is above 300 milliseconds, that's what I'm going to alert. I know that it's going to happen periodically. I'm willing to accept that. But what you really want to be in the world is somehow defining health of an application based off of quantiles, error rate per million, or latency, like the TP99 latency, something to that effect. But you want it to be something that you can externally verify without, a third-party system, if possible. You just want to be able to say, are you healthy, yes or no, and get some good, rich understanding of what health means back, and probably have that be based off of a quantile. This is a hard one, and this is really nice when done well, is can you run Canary requests? By that I mean, can I go and inject a request into the system that is specially marked or flagged so that as that request follows through the infrastructure or through the system, that it will emulate the actual thing, process of buying something or whatever it is that you're doing, but it doesn't actually, at the end terminal node in this graph, it actually won't pull the trigger and buy anything. But as a result, this means that I now have this effective test. Really, really effective test where I can validate the end-to-end, functionality of the system without actually having to go buy something. Hooking this up into monitoring then provides you with a reasonably real-world real-world test where you're using the exact same conduits and the same API calls. Downstream services. So you've got this service. How do you handle timeouts? How do you handle TLS errors? Having some basic understanding of what a service consumes on your network is really important. And figuring out what that standardized process is, or standardized response is. One of the more common problems, unfortunately, we're getting better as an industry, but is how do you handle the retry and back off, right? Do you keep retrying indefinitely? Do you set a deadline timer and then you just give up after half a second, let's say? And there's lots of different ways of potentially dealing with this. I think best practice at this point in time is request comes in, it's got a deadline timer, and every step through your infrastructure, you keep decrementing the timeline or the deadline timer until it eventually returns 0, and then you just stop making further calls. But that requires a fair amount of discipline and coordination because you're now passing a token, not tracing token, but you're passing a deadline timer token that follows your request all the way through the infrastructure and eventually hits a TTL of 0 or responds before then with healthy. And that's really nice, but again, discipline. Yes, these checklists will be made available online. That was the point of why yes. Response codes, are these standardized? One of the most irritating things is to go and make a request for something and get back the wrong response code. Please use standardized response codes, but if you are going to do something funny, or even if you're not going to do something funny with response codes, please document it. And that's one of the things that should be a part of kind of the description of this service. So starting to wind down here, architectural limits. What are the limits of the system? You should be able to have some kind of a high-level narrative that explains to your reader who's picking the service up at some point in the future, at 10,000 requests a second, I'm expecting 200 to 300 megabits of throughput, n number of I/O, and it's plus or minus some kind of like, just give a sense, a flavor of what the system should look like when it's healthy, because at ODark 30, this is really helpful, kind of like summary that will get you kind of in the mindset of whoever wrote this originally and what the expectations originally were. Logging is kind of a pain just because of the amount of data potentially that's involved. If you have or work in a Java shop, the backtraces, if you run like Jetty in debug mode or something, that can be problematic, I will call it. But it's important to tackle your logging. And there's important elements to this. You don't want to have logs hit disk if you can avoid it, especially if you're in like a large distributed environment. You want to have the log come through, never touch disk, and get sent off to some kind of central log processing, because you don't know when the disk on your local box is going to either fill up or you're going to somehow just lose that information. It's stuck in a buffer. It hasn't been f-synced to disk. So you're going to go back and you're going to like have some kind of a forensic activity. You're going to go back, look, and you're going to say, the data's not here. But if you go in and relay this off all in process in memory, you will have a higher probability of seeing the log message because the number of moving parts in reading something from a file descriptor and relaying it out over the network is actually lower than writing to disk. Load shedding, feature flags. How do you set up a circuit breaker? Does your little service that you've put into production have a circuit breaker? Yes or no? Hopefully it does. Oops. Let's assume that the worst has happened and your service, for whatever reason, can't come back online. What then? Right? Have you asked the unthinkable, effectively, which is what happens when your database, your service, just becomes a smoking hole, or maybe there's like some security vulnerability there, and you can't put the service back in line. What then? Right? Hopefully, it's not your login or authentication. Backup and restore. The only thing that I want to highlight here is backups are useless. It's restores that are important. How often do you restore? Right? Real world anecdote. If you have a backup and it returns a size of 0, there is no such thing as infinite compression. You really do need to verify your backups. Seeing a size of 0 in any backup file should be an alarm. And then what's your definition of acceptable loss? So this is an interesting one in the database world, because if you're going to have an OS crash or the hardware goes, just goes missing, you're going to lose some chunk of data that didn't get replicated. It's just kind of a fact. You can potentially do synchronous, over the network writes. Almost nobody does. It's better off to like suck up the potential risk there. But there is risk. So how much risk are you willing to absorb? Right? Are you going to take 1 second of data loss? Are you going to take 5 minutes of data loss? Maybe we're doing point-in-time recovery backups here, and we're wall shipping data off the system. Okay, fine. When I come back to recover, at what point am I willing to have data come back up to a point, and then potentially from there forward I'm going to lose information? How much information there am I willing to lose? Defining that up front actually ended up being a really difficult business discussion, because some people very much wanted that to be 0, not very possible. So what is acceptable? And that ends up being a hard judgment call for a lot of people. If you can get that down to 60 seconds typically, you're in a good place. What's back pressure is a question. So I think so back pressure is when you have a service that's making a request, and when the downstream service that's attempting to respond can't, you will start to see a backing up of requests in the infrastructure. And this is called back pressure, this phenomena where, if this downstream service for whatever reason can only do like 100 requests a second, let's say, and I just sent 110 or 1,000 requests, I've fully utilized this downstream service, and the symptom then is that requests will start to slow down or clog, because no matter what, I can only process work at the rate of 100 requests a second. And that queuing effect is back pressure. There's different types of back pressure, but that's the primary mode of operation there. Deployment. How is the service tested? This is an area that's seeing rapid evolution in the field, it seems, these days. How do you test and deploy? Do you test and deploy to a different environment than your production? Do you want to? What's the probability that your test environment is going to actually mirror production? Chances are probably not. Do you really want to test in a staging environment then at this point in time? How do you roll back? All very good questions, not easy to answer right now. If you're a part of a CI/CD pipeline, what's it look like to monitor your CI/CD in order to find any variance, either in performance or in build or? There's a lot of potential questions there, and value that you can get by monitoring that and finding variance in advance. And last one, production data. How do you scrub that before you kick the data over into staging or UAT? You can't run the entire database through like a fuzzer easily. If you could, you would, but what's that process look like? you don't want to be in a position where you're running your tests on 1 meg worth of data when your actual production database is like 5T in size with billions of rows. The performance characteristics of your test database will look rosy, and you get it into production, and you're going to find out that you're missing an index or 10. So we went through a large list of kind of like top-level concerns, and it really ended up starting to look much more like an audit than it did a checklist. But it turns out that if you come back up out of the weeds of some of these important little technical nuances, there's only like 12 things that you probably need to pay attention to. It's not that much, and it's a reasonable set to go and ask services as they're going into production, hey, have you met these basic common criteria, yes or no? And if you have, that's going to go a long way towards facilitating the maintenance of an application that's gone into production and is going to be maintained for 3-4 years ideally, right? But when you look at what those questions are, they're not technical problems necessarily. Some of them are. Most of them are organizational. One of the interesting things about maintenance is you're dealing with turnover of people and organizational change. The problems that you end up having to deal with that you can't easily express in technology are a result of the fact that the problems are actually organizational problems that you're trying to solve, not technical problems, right? This is not a performance scaling problem. This is an organizational continuity problem. You're trying to solve the problem of turnover, of skill set churn, right? Of the fact that technology changes at a really fast rate. And how do you deal with that? You deal with that through some of the really old tried and true practices that are completely unglamorous, but very important as you continue to consume and push things into production. So again, organizational concerns and technical concerns, more often than not, actually, your concept of production ready has to do with your organizational preparedness, not your technical preparedness. So there's a couple questions here, but thank you for your time. Let's see. So yeah, again, slides will be available online. The handover of services. So that's an interesting one. What normally happens, or what I would suggest is good practice for handover, is you ship it, you run it, you maintain it. You hand it off when it becomes very, very boring, and you find somebody else that's willing to improve it. You need to hand off to some other owner. You probably are not going to have an ops or an SRE team, and if you do, great, but the SRE team is going to put their own baseline criteria in place that's going to say, you have to do these like 10 things, otherwise we're not going to maintain it, right? And that criteria that they're going to lay out is going to probably look a lot like that type of a service checklist there, because they're not going to go and figure out how you did something in some crazy bespoke way. They're going to go and figure out how to maintain it using a standardized way, right? You're going to use a known process manager. You're going to use known logging technology and known API. You're going to use already established tracing criteria. Then you can hand it off, because at that point in time, the ability to debug things, it's fungible. They can dive into service X and then move on to service Y and figure it out. But if you're doing something that's just new and novel and you attempted to innovate, then you're probably going to be on your own. You're going to be carrying that pager for a long time. What kind of risk management do you apply? Or do you rely on documentation left behind? So it depends on what your appetite is for risk, and it depends on the nature of risk. If the risk that you're concerned about is, let's say, security, then you're going to probably have your risk management, framework from your InfoSec department come through and apply a certain set of standards. If your risk management is just uptime, or if the risk that you're concerned about is uptime, then that's a different set of things. That really depends on. That really depends. In theory, your organization has figured out what's good practice and bad practice, and left behind a standards toolkit for you to just kind of adopt. And if they haven't, then that would be a good time to go and figure out how to put in place a good standards set of toolkits and organizational processes. Other questions? Thank you. Yeah, that's not the most exciting of topics and first topic of the day. So thank you, everybody.